we're going to be working with are what they call linear equations. Now, the key thing to remember on this is that linear has the word line in it. And linear equations are going to be equations whose graphs, when the equation is graphed out, creates a straight line. So in other words, these are two examples of linear equations where we've got a straight line here. And then also, even if it's horizontal, or if you had one that was going vertically up and down, those would also be considered linear equations. If you had something that maybe looked like this and then the line drops back down, that is no longer considered a linear equation, nor is a parabola, which is a curved line. Those are not linear equations. Okay, linear creates a perfect line. The points on the line are solutions of the equation, and those are things that we're going to be working with today. Okay, so to start out with, I want to introduce you to two different formats of working with tables, function tables, also known as in and out tables. What we will be doing is I will give you an equation, and to start out with, I'll give you one where it has y by itself. And then we're going to go through and actually substitute in. Now, either of these formats can be used. You have to be comfortable with interchanging between either, just according to different types of assessments. You're not always guaranteed a certain way that you will be introduced to it. So here, the first step that I'm going to do is I'm going to take this equation for y equals, and I'm going to write it out. So I have 2x minus 3, but wherever I have x, I'm going to put a parenthesis just because I know I need to substitute in there. So I have 2 times an x minus 3, and I'm going to do that 4 times because I can see here that they're already asking me to use negative 1, 0, 1, and 2. So I'm going to write them out down here. Okay, so now I'm going to go ahead and I'm going to substitute in the x's that they asked me to use. So they want me to use negative 1, 0, 1, and 2. So I'm going to go ahead and substitute those into the parenthesis and then solve that equation. So y equals 2 times negative 1, which is negative 2, minus 3, which gives me negative 5. Okay, so for my next one, I'm going to substitute in a 0. 2 times 0 is 0, minus 3 is a negative 3. My next one, I'll substitute in a 1. 2 times 1 is 2, minus 3 gives me negative 1. And then my last one is a 2 for x. 2 times 2 is 4, minus 3 gives me 1. Okay, so sometimes you'll see your table set up in this format. That's usually called an in-out table or a function table. Another way is sometimes they just take that and they run it horizontally instead of vertically. So here I found out this was negative 5, negative 3, negative 1, and 1. And just understanding that these are the coordinates that you would graph. Now, the reason I prefer this one is because I am used to seeing my coordinates written left to right like this. So that's why I prefer the table that I have written there. But they both mean the same thing. Okay, so my next step is I'm going to go ahead and I'm going to graph out these coordinates. So my first set is negative 1, negative 5. So I'm going to go over to negative 1, down to negative 5, and I'm going to put my dot. Okay, so that one's done. The next one, 0, negative 3. So over to 0, so I stay there, and I'm going to go down to negative 3, and I'm going to put a dot. That one's done. 1, negative 1, so over to 1, down to negative 1, put my dot. And then 2, comma 1, so over to 2, up to 1, put my dot. Now you'll notice that all of these fell in a line. So now I'm going to go ahead and I'm going to take my line and I'm going to draw through these. Now it is very important that your line extends all the way through your graph. So bear with me here. I have to adjust my line a little bit. Because what I'm saying by using that line all the way through is that any point that falls on that line is a solution to the equation of 2x minus 3. Okay, not just the 4 points that I graphed, but every point that falls on that line is a solution to that equation. So that's why I have the arrows in both directions and I extend the line all the way through my graph. Okay, it's not just the 4 points that I chose. Now, as you guys are working through these, to start out with, they tell you what they want you to use for x. Eventually, they will go away from that and you will get to choose what you can use for x. Okay, so when you get to choose, I just highly recommend using small numbers like 0, 1, 2, 3, or negative 1, 0, 1, or something along those lines. Okay, so let's try another one of these. Whoops, I'm just going to delete this. Okay, so my next one, I'm going to write my equation. I'm going to put a parenthesis where my x's are. And notice that negative is in the equation right there, so I have to make sure that I write that every time. Okay, so the x's they want me to use are these four. So negative 1, 0, 1, and 2. So now I'm going to go ahead and I'm going to substitute in negative 1 in here. So two negatives make it a positive. So positive 1 plus 1 would give me 2. Now I'll put a 0. A negative 0 is the same as 0. 0 plus 1 is 1. Put a 1 in here. Negative 1 plus 1 is 0. And then a 2. Negative 2 plus 1 is going to give me a negative 1. Okay, so here's the coordinates that I'm going to go ahead and graph. And they should follow in a line. If they don't, you should check first, did I graph my plots right? Second, did I maybe missolve any, like one of my equations? So now if I go over, it's going to be over to negative 1 up to positive 2. So there's my first point. 0, 1, over to 0 up to 1. Over to 1, stay at 0. And over to 2 down to negative 1. So you'll notice that once again I have a straight line pattern. Now all linear equations are going to create that straight line. If I had gone through and maybe misdone these two, because a common mistake is kids will go through and plot backwards, it should be very visual right away. Ooh, I did something wrong. I either solved my equation incorrectly or I plotted them backwards. So let's say I had accidentally plotted these two backwards just to show you what it would look like. If I did over to negative 1 up to positive 2, notice that one would be putting me right back over that dot. Okay, well that doesn't really make a lot of sense. Let's say I had missolved this and I had looked at this as a positive 2 plus 1 and gotten a 3 for this back one and did over to 2 up to 3. Over to 2 up to 3, you would see, okay, that doesn't fall on my line. So I must have done something incorrectly, okay? Okay, so now I need to make sure that I go ahead and I connect through my points all the way through my graph. And this is where you're going to want to use a straight edge just to make sure that you're getting it nice and straight through there. And then you put an arrow at each end. Okay. Okay, so let's do one more. This time we've got x plus 5. So I'm going to get rid of this line. So this is a nice, quick and easy one for you to go through and solve. So why don't you pause the video and try this one on your own, and then check back in just a minute to see what your answers should have been for your x and your y. Okay, so that's what you should have ended up with for this number 3, working through that equation. The next part of this lesson is working with fractions. So I'm going to do that as a separate video, as a day 2 video. So you can go ahead and check in on those. But for right now, I want you to practice those working with integers and positive numbers. Good luck with this, you guys.